what we've kind of determined is the smaller ruler, or the ruler that's more precisely defined, gives us a better measurement. I like this question though. So on the first one where it was just broken up into centimeters, what would be the smallest measurement you could make? Yeah, we thought maybe you can go to half a centimeter, although really still that's a bit of a stretch. We can say maybe something like approximately 0.5 centimeters. And for the second ruler, well, that we were able to go down to 0.1 centimeter, and maybe we could say even smaller, right? If it was in between 2 millimeters, in between 2/10 of a centimeter, then we'd be able to say, oh, actually, it's even within that. Maybe it's 0.05 centimeters, something like that. But I think we can confidently say 1/10 of a measurement. Now, here's the big key today. Any measurement we deal with, there is some possible error. That's what I've been hammering at like the last 2 minutes. It's an accurate measurement if it's close to the true value, but we're always talking about degrees of accuracy. So when Carter and I both say that we're 5'9", does that mean we're exactly the same height? No. Unlikely. It's very taller than me. I'm probably just overestimating slightly my height. But we know that we're in the same range. Our measurement is probably pretty accurate. Even if I'm, say, 5'8" and 3/4 or something like that, and he's 5'9" and 1/4 or something like that. I don't know if that's the case. But we may still be accurate even if it's not precisely the same, right? And that's one of the troubles with measurement is we're always kind of trying to figure out what's a reasonable amount of error, what's like good enough for our measurement, and when do we need to be actually exactly perfect, right? If Taj is my accountant, I hope you're good with numbers, and I give him my taxes to do. This is all a bit of a step of faith. And Taj says, well, I think I mostly got it right. The number that is in your bank account is only $1,000 different than the number that we ended your taxes with. I'm probably not going to say, oh, that's an acceptable degree of error. I'm going to say, you're fired, and someone else will try. I probably should stop hiring up my taxes to high school students, but that's probably the biggest issue. But right, there's certain things where it's like, no, I need actually exactly the dollars dealt with of what's being spent and what's gone in those kinds of things. But in some other cases, there is a small amount of acceptable error. And actually, in that topic, with like big companies, there will actually be an amount of error that's acceptable. They won't expect their accountants to get to the nearest cent to be dealing with within some, because there is some error that happens even in spending. But then within accuracy, the degree of accuracy we can deal with is the precision. Basically, how close can you get based on the tool you have. So on those rulers, the second ruler's precision was 0.5. The first ruler's precision was actually 1 centimeter, right? That was actually what the precision was of that tool. We were able to use our deduction skills to figure out, oh, it's probably half of that or something like that. But the precision of that tool was actually to the nearest centimeter. So these two words, they sound similar, accuracy and precision. We're not quite saying the same thing. Accuracy is saying it's very close to the true value. Precision is saying how close can you measure. Do you get the slight difference there? Good, because I don't. All right, so let's take a look here. First of all, what's the precision of this ruler? The precision is to the nearest half inch, right? Oh, by the way, was it actually? Oh, yeah, it was actually. So in this one, the precision here, if we wanted to define this, precision here is every 0.5 inches, right? Or usually we would say every half inch, right? That's how precise it is. But the question that's asked is which one is more accurate? Accurate. Well, looking at this, which one would you think is closer to true?
The measurement 2.
I think so too. It's closer to 2. If I'm looking at this, maybe a way I could do this is like try to make another benchmark in the middle to define this. If I'm looking at here to here, well, it looks like it went halfway is maybe something like that. And it's on the right side of that, so I'm pretty confident that measurement 2 is more accurate. Even though my precision doesn't get me quite as close as I need to be, looking at it and using my deduction, I can say, well, it's closer to 2 inches than 1.5, so I'm confident saying measurement 2 is more accurate. Yeah, look this one. Measurement 1 or measurement 2? Which one is more accurate? Yeah, I think measurement 2 again. I agree. If I had to guess, I would think this is maybe like 2 1/3 inches or something like that. Maybe, 2.3. Oh, thank you, sir. So measurement 2 is closer to accurate, right? It's not exact again, but it's more accurate than measurement 1. Okay, how about the second one? Which measurement is more accurate? You think this is... Now, what would be a helpful thing to do before just randomly guessing? Because you could just do eeny, meeny, miny, mo. What?
I think it's measurement 2.
So sorry, I'm just wondering how. I'm wondering how. So what were you saying?
You can like count in between the lines.
Oh, smart. Okay, so what you're suggesting is like from here to here, from here, this one to here, this one. That's a difference of 30. But there's 1, 2, 3, 4, 5, 6 steps to get there. So to go 30 degrees Celsius is 6 steps. I can be pretty precise. That means if it's 30 degrees for 6 steps, it's 5 degrees per step. So then this is 215, 220, 225. And these won't always have to be labeled, right? But recognizing each one is 5 degrees Celsius lets me actually be quite accurate here. Because this is exactly on this line, which lines up with 220. So I'm quite confident here saying measurement 1 is a better measurement. Now, in truth, if I'm cooking in the, something in the oven, is it likely to matter if the oven is 215 or 220? That's a pretty small difference to actually matter. But this tool is giving me that precise, so nice, I know it's cooking around 220 right now. Now, I'd be curious how good its thermostat actually, or thermometer actually is, but, okay, nice. Now, what's the precision of this? So we talked about more accurate, less accurate, kind of a subjective thing, but compared to another one, right? It's more or less. But now we can say a number. We can say a number for the precision here. So what's the precision of this? How big is each step is what I'm asking. Basically, how big is this step? How big is this step? Yeah, half inch. So it's precise to the nearest half inch. So we can tell it's broken into half-inch chunks. That's what we're asking. How big is each piece that's broken up? Page 1, we're on 166 right now. So it's precise to the nearest half inch. How about this one? How precise are we? Quarter of an inch, nice. Quarter inch. Not meant to be especially tricky. It's kind of like we're setting up definitions so we know what we're talking about. And how precise is this? Well, we already did these ones. It's precise to the nearest 5 degrees Celsius. And notice number and units are still what we want to talk about here. We're wondering how precise to the nearest something, right? Definitely the top one would be different if we were talking about Fahrenheit or if we were talking about Kelvin. Very different. All right. Now this is a matching exercise. So first of all, which of these could we measure 1 1/4 inches on? So now we're wondering about metric versus imperial, and we're wondering about degree of precision. So this one we're wondering about imperial, and we need to be able to measure all the way to 1/4. So I'd be pretty confident doing this one with B. Yeah, I'd be confident with doing B there. Okay, how about 1 1/2? Which ones could I measure 1 1/2 with? Pretty confident though. A. Could I also do B though? Yeah, I think A or B would be fine. Okay, how about 2.1 centimeters? C. How about 2.5? C or D? C still works fine, but so does D. Okay, so what you're going to be doing next is this practice, but I'm going to actually say, frankly, this lesson is really easy. I don't think you're going to need much time on it, so I want to just continue cruising along. We have some students who've been asking about certain fun lessons that I would love to be able to do. So I do want you to do this practice, but we'll just come back to it. Okay, we're going to keep on cooking along. So this is what you're coming back to. But now we're getting into this precision, accuracy, and uncertainty. So within this, degrees of certainty, degrees of uncertainty. Basically, here's the big idea. What's the biggest and smallest it could be within this range? This is the whole thing when we were talking about on a graph yesterday. We were saying, I measured this, I measured this, I measured this, I measured this. Let's say it was the time that it took for, me to throw the rock to Adam. We're basically saying, well, if my reflexes were faster than I think, what would be the shortest possible time? If my reflexes were slower than I think, what would be the longest possible time, right? So maybe we're saying from, from me to Haley, from me to Cole, from me to Gia, from me to Adam, or something like that. But with each of these, there's a slight bit of range of what could have happened, basically from here to here for one. Okay, so first of all, let's just start out looking at this. We just did this. I don't care if you fill all of this in. We just did something very similar. The big question though here is, first of all, which one's most accurate? Which ruler? The one that has 1 inch precision, half inch precision, or quarter inch precision. Which is the most accurate? Quarter. Yeah, we can say pretty confidently it's something slightly bigger than 1 3/4 of an inch. Now, what's usually better? Instrument with big precision or with small precision? Yeah, we want small precision. We want it to be more accurate. Although, is there a point where that becomes a little bit redundant?
Yeah.
Like, if I'm measuring the distance from here to my house, do I care about the nearest millimeter? Right, in that case, it's kind of unnecessary. This is where we talked about, like, when you're converting, let's say I have a distance for me to drive to visit my parents in Red Deer. I think it's 186 kilometers. This is probably good enough. It's probably not a big deal that the distance is actually like 183.134789682115, something like that. And would this all actually even be meaningful? Like when we talk in science about measurements, at a certain point, these numbers are lying anyways, right? There's so much baked in potential error that to define something this precisely, that there may actually be some inaccuracy in, is actually sort of untrue. So you're always balancing the, like, for how far or how big is the number, and what degree of precision do we need? So the distance from here to Red Deer, well, that could probably be measured to the nearest kilometer quite easily using, modern tools, but it probably can't be measured to the nearest, like, millimeter, very realistically. And if we try to say we can, we're probably more full of bluster. Okay. So what I'm trying to say here is there is some uncertainty, and this is that plus or minus, right? That's what those error bars are talking about. So if we were measuring it at 2 centimeters and it's plus or minus 0.5 centimeters, by the way, that's a ridiculously high uncertainty for a measurement. If you're talking about a quarter of the measurement worth of uncertainty, that's a little bit scary in a simple distance measurement like this. But what that measurement is saying is it could be all the way down to 1.5, it could be all the way up to 2.5. And this is why when you see the polling data for the election and it says that, the Liberals are polling at whatever, 42% or something like that, plus or minus 5. And the Conservatives are polling at whatever, 41%, plus or minus 3 or something like that. It tells you there's a bunch of things that could happen in the election, and that's just talking popular vote. These numbers might not be accurate right now, but it's something in this range. Or sorry, I think it's actually like 30 something, but whatever. Let's say these were the numbers. What this means is they could be anywhere from 47 down to 37, right? That's the possibilities for this piece of data. And this one could be like 44 all the way down to 38, somewhere in there. And it's probably actually, if this one's higher, this one's probably lower in polling data and whatnot. But it's saying there's somewhere in here. So though this one looks much higher, what we actually really see is that there's a higher degree of uncertainty in this data, and both of them have a lot of numbers that overlap. Now, for this course, and this is a fairly oversimplified way of dealing with it, the uncertainty is always half the precision of the instrument used. And you guys were kind of recognizing this when we were using the 1 centimeter or half centimeter. We were saying, well, we can get a little, inches. We realized we can get a little better than that, but maybe we can't get all the way there. So like when it was 0.5 centimeters per tally, you guys are able to say, well, it's probably somewhere in between there. But so like looking at this. Okay, this one, let's say, okay, the measured value, including its uncertainty. So what would you say this at? And then remembering the uncertainty is half of the precision. What do you think is a measured value for this first one? Okay, but remember with inches, I'm using these fractions.
Okay.
So what if I said it's like what if I said it's 1 3/4 of an inch? But now we want to add in this uncertainty. So plus or minus, and we've said half of the precision. So what's half the precision here? What's the precision measure here? Half inch, right? So what's half of half? Plus or minus quarter inch. That seems fine. By the way, those of you that are like, I hate fractions, just use decimals. It's okay. In this case, I'm not really trying to test you on fractions. With imperial, we usually use fractions, but if you're like, I still suck at that, just use decimals. Case like this. Okay, what do we think this second one is? What would be your guess of where we're at about? Probably 2 and 2 1/4. That sound fine? By the way, I'm also usually going to make my measurement. I won't get any more accurate than like half of the range, right? I'm not going to try to define this as like, I recognize it looks like it's closer to half than to 1/4 to me, but I'm not going to strain myself and say, oh, I think it's exactly 2 3/8 or something like that. My measurement's are only half an inch. Don't worry too much about it. Okay, so I'm saying it's like 2 1/4 plus or minus 1/4 inch. So that seem fine? No, it's 2 1/3. Okay. But the big thing we're trying to show right now is this is our measurement of uncertainty. This is how certain I am or not. Plus or minus this much from my measurement. Okay, how about this? Now this gets a little bit more real. All right. How's that look?
Yeah.
Kind of 90-degree angle? Maybe I'll get my protractor, make it exact. Okay, so I think this is about 5. Oh, that's a line now. Sorry. Back to your record, Mr. Voice. So I think it's about 5 centimeters. But now, okay, plus or minus how much? 0.1? No, you're right. There's 0.1 is each precision, but what do we say we do in terms of deciding uncertainty? It's not by each precision, it's half precision is what we think we can do this with. So we're saying plus or minus 0.05 centimeters here. Right, so we can go to within half of what our precision is. Each of our steps is 0.1 centimeters. Right, that's measuring by 1 millimeters. Although I do see some significant issues in it in terms of being level. But the way we want to determine uncertainty is plus or minus half of what we can measure to. Does that make sense? So we're measuring to the nearest tenth of a centimeter, so we're uncertainty is half that. In this case, I'm recognizing each step is 5 degrees Celsius, right? 5 degrees Celsius. So we determine that this one is 220 degrees Celsius. So now what's our uncertainty if it's half the precision? Say that again, sir? No, our uncertainty here is 5. Or sorry, our precision is 5. So what's half of our 5? Yeah, just plus or minus 2.5. Oh, it doesn't. Good point. It doesn't say it, but each tick is the degree of precision. Great point. Great point. So each tick, even though it actually is 30 that is apart, each step is still only 5 degrees, and we can do that by taking this 30 and dividing it by the 6 steps in between. Yeah, thank you for clarifying. Good question. So 220 degrees Celsius plus or minus 2.5 degrees Celsius. Yep. Now, this part, I think you guys can find a little bit simpler. Now all this is saying is, okay, now let's go backwards. You've been given this degree of uncertainty. What could this be? What is the range this could be? So what's the smallest possible value here? So 25, basically 25 minus the 0.5 centimeters. Well, that starts at 24.5. It could be as low as 24.5 for this measurement. And what's the highest it could be? Yeah, exactly. So all we're saying is take that number and apply the minus possible, apply the positive possible, and then if we were kind of trying to do this, what we're really saying is like this data point is 25, but it could be as high as 25.5, it could be as low as 24.5, and it could be anywhere in there. That sort of makes sense? That's what this is trying to tell us. Is this thing I measured is somewhere in between 24.5 and 25.5, with 25 as my best guess. Okay, 10 inches plus or minus a half inch. Well, as small as possible then is 9.5 inches. And the biggest possible is 10.5 inches. And then here, 220 degrees Celsius plus or minus 5. Well, smallest possible is 215 degrees Celsius. Smallest, or biggest possible is 225 degrees Celsius. Plus or minus 5 degrees Celsius is what we've been told here. Who's looking at this like, okay, I think I kind of get what's going on there. Anyone still a little bit uneasy? Or are you guys mostly concerned about how many holes are in the ceiling at this point? Just counting holes in the ceiling. Okay, fair enough. Well then, why don't I let you practice? So notice I've asked you actually to do quite a bit of practice today. Really what we're trying to do is we're trying to do 4.2 and 4.3. Don't worry, this will pay off tomorrow if you're able to do it. Okay? So try to get both of these done, and if so, do them. Good?